Hey everybody, welcome to your quiz review video. You see quiz dates here. So let's get to number 1. This is a step function. It's made up of the horizontal pieces that do not intersect. We are finding the domain and range. Domain, remember, is the x values left to right. So if we look at the far left, we have a closed circle on -8. So that will be a bracket with a -8. And then that horizontal piece ends with an open circle at -5. The next piece starts with a closed circle on -5. So it does cover that value of -5. So there's no actual break in the domain at -5. Then that piece goes until an open circle at -2. And then the next piece starts with a solid dot at x equaling -2, so it fills in that x equals -2 space in the domain, so there is not a break in the domain at x equals -2. So this one goes across until there's an open circle at 4, and then the final step starts with a closed circle at 4. So again, there is no break in the domain at 4. And we go until 9, x equaling 9. And there is an open circle on x equaling 9. So from -8 with a bracket, comma, 9, close a parentheses, there is no break in the domain. Now, let's look at range. Range goes from bottom to top on the y. And if we look at the y values that get used, it's only the y values where the horizontal pieces are located. It's not the in-between pieces. So we list that as a curvy brace, and we list those individual y values and end it with a curvy brace. We're not including all of the pieces between, so we list the individual values. Now, let's look at 2 through 5. We are using these functions. Okay, we are using these functions. So on number 2, find f of x plus 1. So in the f function, everywhere there was an x, we are going to replace it with x plus 1. So when we expand out x plus 1 squared, remember that's x plus 1 multiplied by x plus 1. So that would be x squared plus 1x plus another 1x plus 1. And then we will need to distribute the -10. We'll get -10x minus 10, and then bring down the plus 7. Now, we have a lot of like terms to combine. We do only have one x squared term. For the x's, we have 1x plus 1x minus 10x. So that gives us minus 8x. And then for the constants, that's plus 1, plus 7, and minus a 10. So plus 1 minus 10 plus 7. And that gives us a plus, it's an 8 minus 10. That gives us a plus 2. It gives us a minus 2. So there's our solution. All right, let's look at 3. We are finding g of -4. So we're using this g function. Everywhere there was an x, we are going to replace that with a -4. And so -4 to the 3rd power, 4 times 4 times 4 is 64. Negative times negative times negative is negative. Then plus 16 minus 13, and that equals -61. So g of -4 is -61. On number 4, we are using the f function again. So any x gets replaced with, in this case, the 2. This 2 is the x. So then 2 squared is 4. 10 times 2 is -20. Then plus 7. And that gives us -9. So f of 2 is -9. On number 5, we are using the g function. So everywhere there was an x, we are going to replace that with this a. And there's really nothing to simplify here. This is just a to the 3rd minus 4a minus 13. And there are your functions. So let's look at number 6. We want to write these steps and formulas for finding the equation of a line through these 2 points and writing the equation of that line. We have 2 points. We need an equation of a line. We need to find slope. That slope would be y2 minus y1 over x2 minus x1. So then finding that slope, 2 minus 1 over 6 minus 4, that slope is 1 over 2. Then we need to use y minus y1 equal to m times x minus x1 to write the equation of the line. So plugging that in, y minus, here was x1, y1, so y minus 1 will equal that slope of 1/2 times x minus the x coordinate 4. Distribute the 1/2. Y minus 1 is equal to 1/2 x minus half times 4. Half of 4 is just 2. And then we do want this in slope-intercept form, so we'll add the 1. So y is 1/2 x minus 1. And there is the equation of the line. On 7, it wants us to discuss the difference between when to use parentheses versus brackets in the notation. Parentheses are when the value is not included, meaning it is an open circle, or it's an infinity, or it could be an asymptote that the graph is approaching. We use the brackets when the value is included. We use that with a closed circle. And we use that when the graph does actually touch the point. Now, As far as inequality symbols go, for the parentheses, we would do those when the symbols are less than or greater than. We use the brackets when we have less than or equal to, or greater than or equal to. The or equal to means we use the brackets. So let's look at 8 and let's find the domain and range for each of these. On number 8, the first one, domain left to right. If we look at the left edge, this graph is going left forever. If we look at the right edge, it's going right forever. So that interval is negative infinity to positive infinity. We always use parentheses on infinities because we can't actually reach them. Or you could write that as all real numbers, that capital letter R with an extra stem on it. For range, we look at bottom to top. This graph does have a bottom at 3. It does touch that 3, so it's a bracket 3, comma. We look at the top. These arrows are pointing up, 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 up. So that goes to infinity. So bracket 3, comma, infinity, parentheses. Now, let's look at the second one. Domain, we're going left to right on the domain. So if we look at these pieces, the left does start at -5. It's a closed circle, so it's a parentheses. That piece goes from -5 until +1. And that's a closed circle at +1, so it is a bracket. Then there's a gap, so it's a U for union. We start over again at 2, and that's an open circle, so it's a parentheses, comma. We keep going all the way to 5, and that is a closed circle, a dot, so it stops at 5. Now, looking at our range, bottom to top, our bottom is -2, and we do equal that -2, a closed circle, so it's a bracket. So as we go up, we do have an open circle at y = 1, but this curve of the graph does exist at y = 1, so there's not a break in the domain. It keeps going up until we get to 4, and we do touch that 4, so it is a bracket. On C, the last one, the domain, if we look at the left, that arrow is going to the left forever, so that's a parentheses with a negative infinity. That piece ends at -1. It's a closed circle, so it's a bracket. Then union, and that second piece starts at 3 with a closed circle. And that right edge continues to infinity. We always use parentheses on infinity. Then range goes from bottom to top. The bottom is at -1, and this whole red line is on -1, so it's a bracket, comma. There's no gaps here because this blue piece does start on the domain at -1 as well, and it goes up into the left, keeps going up, up, up forever, so that will go to infinity. We always use parentheses on infinity. So there are your domains and ranges. On 9, we're looking at the steps for completing the square. Okay, so we need x² and x on one side. And then we use the bx coefficient, whatever the coefficient of x is. Okay, and then to do the complete the square, we half it, box it, square it. And then we add it and undo it. Half it, box it, square it, add it, undo it. So let's look at number 10. We need the x squared minus 6x on one side. We put a plus blank here, equal to, we'll add the 14 to the other side, and we need to add a blank there as well. Now, we have the x squared and the x terms on one side. Now we use the bx coefficient, the b, which is negative 6. Negative 6 divided by 2 is negative 3. We halved it. We put a box around it. Now we're going to square that negative 3. That gives us positive 9. So we will add the 9, and we will undo it by adding a 9 on the other side to keep the equations balanced. Now, we did this so that these three terms would be a perfect square. And they are the perfect square of x minus 3. Then on the other side, that's equal to 14 plus 9 is 25. Now, the direction said to solve this by completing the square. So we solved this. I goofed. 14 plus 9 is 23. So when we solve this, we need to take the square root of both sides. So x minus 3 equals plus or minus square root 23. We need the plus minus because we took the square root in order to solve. Now, to solve this for x, we would need to add 3 on both sides. So x equals 3 plus or minus the square root of 23. And there are your solutions. Now, let's look at 11. We want to move the 10 to the other side. We also want to factor out this 3. So we'll factor out the 3. We'll have our parentheses, x squared minus, divide 12 by 3. That's going to be 4x. And here's where we want our plus blank. And then that's going to be equal to negative 10 that we moved over plus a blank. Our blank on the left side has a 3 on the outside of it. So our blank on the right side needs to be multiplied by 3 on the outside of it. So now we have x squared plus bx, the 4 being that b. So we take negative 4, half it. It gives us negative 2. We put a box around it. Then we square that negative 2 to get us 4. We did half it, box it, square it right there. Then we add the 4 and undo the 4. Undo as in balance. Then bring down the 3. The values in the parentheses are a perfect square. They're the perfect square of x and the number you put the box around, minus 2. And that's equal to negative 10 plus 12. So that's equal to positive 2. Now, to solve this for x, we need to divide both sides by 3. So then x minus 2 squared will equal the fraction 2 over 3. Leave that as a fraction. Then we need to square root both sides. Take the square root of both sides. So then x minus 2, undoing the square root, is equal to plus or minus square root of 2 over 3. The whole fraction, 2 over 3, is inside the square root. Then we would need to add 2 on both sides. So x would equal 2 plus or minus the square root of 2 over 3. There are your solutions. On 12 and 13, we are solving by the square root method. If we look, there is only a single variable x. So we want to move everything away from that x. So we'll add 5 on both sides. So then x plus 3 all squared would equal 20 plus 5 is 25. Now we have everything on this left side in a square. So here's where we want to take the square root. That square root undoes the square. X plus 3 is equal to plus or minus the square root of 25 is 5. So then we need to subtract 3 on both sides. So x equals negative 3 plus 5, and x equals negative 3 minus 5. So x here equals 2, and x equals negative 8. Those are our two solutions. Okay, negative 3 plus 5 gave us the 2. Negative 3 minus 5 gave us the negative 8. Let's look at 13. Similar idea. We have only a single variable x, so we want to isolate it. First thing we want to do here is divide off that 2. And then x minus 5 all squared will equal 7. Then we need to take the square root of both sides. Square root undoes the square. So x minus 5 will equal plus or minus square root 7. Anytime we take a square root to solve, you use the plus minus. And then to finish this, we need to add 5 on both sides. So x would equal 5 plus or minus the square root of 7. Since the square root of 7 is not able to be simplified, we leave it here. On the previous problem, the square root turned out to be a whole number, so we could simplify that. All right, last thing, let's look at transformations on number 14. Everything except the x and the square cause a transformation. So if we do this in order of operations, inside the parentheses first, that plus 1 moves left, right, but feels backwards. So that moves to the left 7. That moves to the left 1. That moves to the left 1. We do the parentheses. The exponent is the function, so there's nothing to work out there. Then we do multiply or divide. That multiply by 1/2. That is a vertical compression because it is less than 1 by a factor of 1/2. So everything will shrink by a factor of 1/2. And then that was for the 1/2. And then the add and subtract come last, that minus 7 That's an up and down, and that feels normal directions, so it will move down 7. And here are the transformations. Let's do the same thing on 15. Everything except the x and the square cause a transformation. Order of operations, start inside the parentheses. That x minus 2 moves to the right 2. Yes, that feels backwards. Then we look at the multipliers. We multiply by a negative 3. And that does 2 things. The negative reflects over the x-axis. The 3, because it's bigger than 1, does a vertical stretch by 3. Everything will stretch 3 times as tall. And then this plus 4, add and subtract come last. The plus 4 is added. That's an up and down. So that goes up 4. And here are your transformations. All right, y'all, there is your quiz review. Good luck on your quiz. Bye, y'all.